This week on the Escape Key project, we're setting up a flashing air grill. So this is the sort of air grill you'd find in any office or building for ventilation. It's flashing not A there. I've put it in a dark room so that you can see it, but that's the main concept that I had. And the idea being that you would slide it across and be able to see these words, and I'd probably add a switch to it. I'm using two programs for this one. The first program I'm using is Shaper. Shaper, that's SHAPR 3R. And it's quite a tricky one to use, actually, quite complicated, and I found it a little bit unwieldy. I'm going to persevere because it's very powerful, but for the actual grill aspect itself, I used Tinkercad. Tinkercad is seen as a children's 3D design package, but actually I'm using rectangles here, and it's got the advantage of being very easy to control. So you can see me using the little cube there in the corner. I can make something transparent. So here I am testing out the inner grill, so it makes sure that it fits inside this little channel that I've created for it. And you'll see why I made that in a little while, because of course this took quite a few iterations. I ended up making 7 separate pieces, and a lot of this is my own fault. So this is the first one, really good on that side, but if I flip it round, you'll notice I didn't push through the holes fully on the T. That's on Shaper 3D, so quite frustrating. This one was okay, but then I recognised by stopping it halfway through the print that it was thin enough for me to test that it fitted, and I could put the screw holes in. Finally, this is the last one, so I've added the screw holes with placement for the heads, and I also put some tape on the back because I realised that the light was going through. As for the grills, I made 4 of these in the end. This one was just too thin and inflexible, didn't fit anything in comfortably. This one was far too thick, and so the actual inner panel was far too wobbly. Again, my measurements should have checked that. This one, I missed a gap out, so actually it broke at the end, which I don't want. Finally, this last piece, and this was designed in Tinkercad in about 10 minutes actually, because I had all the measurements. It's now got a really nice channel where I can slide in the grill and slide out the grill. Fits perfectly. So I set up a little circuit on my Arduino Uno. I've got 7 LEDs there on the breadboard, and I'm going to connect a power supply, and I've got all of the resistors going straight to ground, and I've got them blinking, so it's more indicative. This is me testing out the LEDs because I've placed some of them the wrong way round. Really easy fix, and I can see them flashing now perfectly. And then I'm going to install it inside. This is a standard 2-plug box that you can get, to junction box from any sort of DIY store. Fits into plasterboard, fits into normal walls, and this cost £1.19, so it's a really good way of finding a framework. So there we have it, my LEDs are in place. I'm popping my Arduino with a case into the box and folding it gently in. And I would say here that in a future project, if I was to adapt this further, I'd get a diffuser plate, and what that does is it breaks the light out so that they're not so obviously LEDs. I would also say that despite the impression you get from plastic print, you can actually see through it. So I actually had to add a whole load of electrical tape to block the light. This was embarrassingly pointed out to me by my 13-year-old son. He said that the light would be too bright and it would shine through the plastic, but I did need to use white plastic because all of these ventilation plates are white, or at least off-white, slightly cream perhaps. So I used this electrical insulation tape. Again, this was £1.20, and the actual print cost for the plastic parts was about £2 in total. So it's actually quite a cheap product to make. I've got £2 for the actual plastic pieces, £1.20 for the plastic box, and various other peripherals, and of course you've got the Arduino to include, and the breadboard. But once that was all in place, I could then screw in this plate onto that junction box that you saw earlier. So you can see the lights flashing. I probably wouldn't recommend using a crosshead screwdriver, which is electrical for this, because you don't know the tolerance. But I actually had worked on this a couple of times now, so this is about the fourth time I've screwed it in, so I'm quite familiar with when it stops. And I've made enough of a depth for the top of the crosshead so that it sits flat. So here it is, and I'm using it to, the light's not clear here, but I'm using this to demonstrate how we can show that the word is being hidden and then being revealed. And then of course here it is in situ in a dark cupboard. So in a dark room, when it's slid open, you will see that flashing. And I'd probably add a switch to that.